enabling the circular economy, circular products. And this is what it's all about, because in-mold structural electronics enable more sustainable product design. And products that actually then can be circular. And we'll now find out. We have the Finnish company TactoTek and this wonderful gentleman, Karthikesh Raju, and he will explain what it's all about. So,
Thank you very much.
So good to have you. This is your stage, and then you will have the chance to ask him questions after his presentation. This is also true for you joining us online. So, have the questions ready. He'll explain what in-mold structural electronics are, and then later we'll bother you with more questions, all right? So
Absolutely.
Please, send a stage for you, Karthikesh. I'll leave you to.
Thank you very much. It's always a demo effect whenever we have to start, right? All right. I don't see the presentation over here, so. All right, let's start. I mean, we can start with this, right? It gives me a great pleasure today to stand over here in front of you all and talk about something that was partially covered in the previous talk. Something about design, something about sustainability, and something about cost. And what I'm trying to bring over here is all the three parameters together. I would be pivoting between two different topics, the topic of design, and how can you actually create eye-catching design like the Adifo chair that we had previously. But then, how can we make that intelligent? Then I would pivot over and talk about how does design become sustainable, and how can you evaluate a design whether it's sustainable or not, pretty much at the early stage of the design rather than at the later stage of the design. And then finally, we'll look at how we can actually build a metric that can actually give the designers a method by which they can say whether this design is good or not. So let's start. As said, I'm Karthikesh from TactoTek, and I look at products and marketing. So let's break this down. I mean, you all know this, I'm sure. Some of you actually have this in your house. A wonderful product, a standout design, a great take on a very simple home automation platform. So this is something where the designers don't talk about features. They talk about the user experience. They talk about the workflow. That's what design should be about. But then today, as a designer, you have other challenges. You want a design that can stand out, a design that can be sustainable, a design that not only involves the user, but also makes him feel that he's doing the right choice. And when we mean sustainability, it's actually a word that everybody wants to have, but it's not just sustainability from a raw material standpoint, it's sustainability from a life cycle analysis standpoint, a complete cradle to reusable sustainability. A designer also needs to look at supply chain. You don't want to have sub-assemblies come from one part of the world, another sub-assembly coming from another part of the world, and then you bring all of that to a centralized location, you assemble that, and then wow, you have a product. That's an efficient way of doing things, right? And then finally, there's the cost imperative always. And this is what the designers need to grapple, two different parameters that they'll have to consider. And why is that so? It's so because any human-machine interface, anything where you have an electronic part and a mechanical part come together, you have two different worlds where people have to go between. In the mechanical world, you have the form, you have the shape, you understand how it looks, how much it weighs. So if you take the nest, that's the rotary dial. That's the industrial design part of it. But then you have the electronics world that defines the function. It defines the interface. How do I talk to it? Do I talk to it? Do I touch it? When I touch it, does the light come out? So this is how the user interfaces with that particular design. The problem is, these two don't overlap much. You actually have very little that combines these two because that's the way the design world works. And what you have is designers' worldview is this worldview. If you have such a narrow worldview, you actually suboptimally design stuff because you know the great designs you book forward will never become part of reality. And this is the designer's dilemma, and this is the design for constraints that we have to change. Now let's take a crystal ball and see what can the world be if this freedom was removed, it was not there, if this constraint was not there. The first thing is to take and look at what self-sustaining electronics, structural electronics would be. Imagine this. Let's say you have a door trim that's illuminated. Today, that door trim is static for the period of the car. That's it. You get the car in 2022. That car is going to be with you till 2028. That's it. You just need to keep looking at it. But that's not the way this world operates. This is a completely different world, right? Every 10 months, you get a new software, the phone looks different. Yes, the shape is the same, that's the mechanical world, but the phone looks different. Imagine this, that you actually can reprogram that door trim. You start with something, you open your app, and voila, you actually have a completely new door trim. That's a new way for you to be able to interact with that particular car. And that is what we want to be in. We are not there. It's still a big world far away from. That's simply because people think of components in a box. You have all the functions and all the controls separately put in a box, and you have a structure around it. This is what designers grapple with today. What we did is to bring components into a structure. What I have in front of me is that example. Imagine this is the overhead control panel of a car. This was what we showed 3 years ago in IMSE, where all the components have been integrated. The control is still in a separate board, but the components have been integrated. This is 3 millimeter stick, much, much, much thinner than what you have today in the central console, much less weight, heavier. The next step in all of this is to actually have integrated functions and controls. So everybody in the audience, this is the world's first digital plastic part that can be programmed. What you have over here is all integrated controls, as well as a digital interface that can make the plastic structure take on different properties. And this is what IMSE is all about. In-molded structural electronics is an innovative way for us to be able to build smart surfaces. What exactly is this digital part? Let me show you with an example. You can see over here, I have light. I make the light live actually here. This light can be completely programmed because I have a digital interface. This means I have a bus that I can make this act in different ways. Think of this example. An example where this is part of an ambient light in an automotive vehicle, pretty much in the center console. I can use this because I can program this part. I can use this to tell me whether my phone is charged or not. I can use this by connecting it to a system to tell whether I'm driving too fast or not. I can use this also to have haptic control. I can use this to have control the center console and the software that's driving the center console. One single part, multiple applications in one single segment. The same part can also be used in a home automation context. This is what I call reusable, sustainable plastics. You don't need to build again and again. And this is the innovation. And how do we do it? IMSE is all about starting with film. You have a film, and then upon that particular functional film, what we have is a two-dimensional structure. In that two-dimensional structure, with silk screen printing, we actually print the conductive and the dielectric layers. Once you have printed the dielectric and conductive layers, you actually mount all the components with SMT. So you can see the LEDs over here that are mounted, all in the two-dimensional realm, flat films. Then, with our unique technology, you can actually mount an SIP, which we call system in package, a microcontroller. This could be any microcontroller, by the way. It could be even a Bluetooth module. It could be anything that can enable you to communicate. Then, what we do is thermoform the whole thing. Thermoforming gives it structure, gives it shape. So you have now a thermoformed material, a thermoformed film. Then final stage of it is actually molding it. So you have now the molded part and a decorative part over here. All of this is joint work that we have done with Covestro. Covestro film, Covestro resin. So I would have to say, as joint partners, we have the world's first digital plastic. And this means we have thin embedded structures, very, very lightweight, very sustainable, and multiple applications. Now let us turn the whole thing around and see what does this mean from a sustainability angle, and why is this important? We know that legislative realms are making great challenges towards the electronics industry because we want to have energy efficiency, we want to have our strategies regarding recycling, regarding recovery, regarding all the other rethinking how we would build electronics. We also have the whole world is wanting us to be able to move towards sustainable materials. But the point is just having sustainable materials doesn't solve the problem. Yeah, I want to have recyclable materials, but nobody cares about the recycling process at the back end, right? So this is very, very important that we need to look into that. And then if you take the same example and say, okay, well, let's put electronics into structures, but if you want to have a light line, previously the structure would have a complete PCB. And PCB inherently is subtractive manufacturing. You have the full copper, and then you edge away copper to be able to fit a few LEDs over here. So it's a full board that's highly unsustainable, and then an edged away process. Is that really good? What we really need to be able to make things sustainable is an additive manufacturing technique, not the PCB-based manufacturing technique. And finally, recycling. I mean, a simple question. How many of you guys have phones lying around in your cupboards that you have not even charged, seen? This is all the e-waste that we have. We need ways to be able to collect that. We need ways to be able to recycle that. Taking this forward are, different drivers in different industries. We all know what's happening in the automotive world. I don't need to cover that. The whole show is about automotive sustainability. We all know also that consumer electronics is talking about recyclability. But let me give you a simple facet. Have you all checked in bags when you fly? Have you had a conversation with the gate agent when you have excess baggage? Do they let you go, or do they make you pay? They always make you pay, right? A simple facet is there's a direct correlation in this aviation industry about weight and sustainability. We came to know from an aviation tier that 1 gram of additional weight is equal to 1,000 euros per aircraft per year. Let that sink. If it's Lufthansa, that's a huge amount that they can actually save. Now we, with our technology, validated it and verified it for the aviation industry, and we came to know that actually we can reduce 90% volume and 40% weight. 90% volume and 40% weight on a single PSU unit. So this is the unit that goes on top of a seat where you have the attendant call button, you have got the lights. For a narrow-bodied aircraft, that's about 30 seats, 60 PSUs. 90% volume reduction, 40% weight, that's a huge number. So now I touch upon the topic that was actually raised previously in the previous talk, cost, right? Whenever you look at new innovation, the first thing that people ask is, what's the cost? How can I evaluate what is called the total cost of ownership? It's a great tool. It's there for many, many years. It's been a wonderful way by which financial analysts say, this is good or this is bad. It's very binary in nature, right? And typically, a total cost of ownership looks at 2 variables, the CapEx, the cost that you take to buy a plane, the cost that you have to put a plant in place, the cost that you have for equipment, machinery, everything. The second part of it is the operating costs. The operating costs about what it takes to run the flight, what it takes to run the plant, the fuel, the supplies, the upgrades, any other maintenance that go into it. All of that compositely brings it together, and then you have a total cost of ownership. Simply put, it's a brilliant way by which you can actually take cost and you can actually take time and put both of them together and say, this is how much the cost is going to add, and this is how much the asset is going to cost. But has anybody thought over here, it is missing everything related to circularity? We don't talk about the savings in copper when you do subtractive manufacturing. You don't talk about the way in which you can program plastics and use the same part last a lifetime. You don't talk about optimized supply chains. None of it is captured actually in this framework. And this is missing because it's actually ignoring sustainability and circularity. And that is problematic when you have new disruptive innovations, because you start looking at new disruptive innovations through the lens of the old. And this is where we need to think differently. And what goes into this? Let's take a look. I mean, I'm sure a lot of you would have seen about the R strategies, but some of that is actually relevant for our technology is recovery. We can recover, and our aim is to recover 100% of the silver over here. So that's the first thing, chop it, shred it, recover all precious metals. But that's not the only way to do it. We are, in fact, working with Covestro to be able to find out new recycling techniques, including bio-based or chemical recycling. The next one, once you recover, you should be able to recycle the silver rings. That's something that we have for subsequent manufacturing. The third part is to reduce. And that's important, because if you can reduce the number of sub-assemblies, that means your supply chain costs are dramatically different. The fourth one is rethink. If you have a door trim, and if you need a PCB for every single door trim, if you need every single door trim being manufactured and then stored, that's not a nice way to be thinking about product variants. Now what you have is a very efficient way for product variants. You can actually have a part like this, embed it with all the electronics you want, and then have a means to activate the electronics whenever you need. That's a very different way to think about a vehicle, think about any physical structure for that matter. Even that chair over there with ambient light that was mentioned, you can think of it differently. Have that chair, subscribe to it, and then when you want, you have ambient lighting. When you don't want ambient lighting. And then finally, refuse, as in change the way in which you integrate and make electronics and plastics come together. So if you look at it and say, OK, these are the cost parameters, these are the parameters that I actually need to have in my TCO, then you have a completely different way to look at cost. And this is what we call total circular cost. Total circular cost starts with TCO. Of course, you need to understand what's the cost that you have. But then we want to build new parameters into it, impact parameters like how do we reduce the carbon footprint? How do we reduce the number of steps in assembly because we don't need to ship parts all over the world? How do we reduce the number of structures because we have monolithic structures? The second one is to rethink product variants. How can we actually build new product variants without having to build full variants? That's a new way to think and reuse. And then finally, recycle and recover. So this is what we call a framework that can enable designers to think about it early in the design phase itself. What the entire conversation today about sustainability is post-consumer sustainability. What we want is, if you design it right, you will actually get the right sustainability, rather than design it one way and then think about sustainability later on as an afterthought. And this framework should give the designers to understand both the financial metrics as well as the sustainability metrics, bringing all of this together. Let's take an example. Let's go back to this circular part, this wonderful digital plastic that I showed. An equivalent, you have seen it in many cars. It's always there. 41 parts, 2 different PCB. Quite heavy, quite bulky. A monolithic structure that we have over here. Intuitive design, simple, small, single molded part, 90% less in terms of thickness, 50% less weight. This former cannot be programmed, the latter can be programmed, multiple use cases. Just think about it. Weight savings, volume savings, sustainability savings. Take all of this and put it into this TCC metric. We see the benefits, but how does it translate into metrics? When you do a life cycle analysis, you get a score, right? Using life cycle analysis to understand the different R strategies, and then understanding that you have less tooling costs because you have less number of parts, you have less PCBs, you have an optimized supply chain, you have optimized production. We can say that this method with IMSE for a central console panel is at least 40% having a better circular score, which means it's 40% more circular than what you would have if you built things the traditional way. And that is a big number. And that translates to probably range in an EV. That translates to savings in an aircraft interior. That is actually what sustainability should be. So finally, just to conclude, I would like to say a parallel, give a parallel. Most of the time we talk about GDP. GDP is a way to measure the wealth of a nation. But GDP is not the way to measure the wellness of a nation. A nation can be rich, its citizens can be poor. TCO is exactly that same problem. It's great to measure the costs of a product. It's great to measure the cost of an asset, but it's not great to talk about it because it completely ignores sustainability. And what we want is that particular metric that new innovations can be judged against that can stand the test of sustainability. What I have here is an open call to everybody, all the manufacturers, all the material people. When we talk about digital product passport, try to look at it from a TCC perspective so that designers can know very, very early on what works, what doesn't work. Don't come to the problem late in the cycle and say, I want to recycle it. Come to the problem very, very early on. Give the designers the right tools, give the designers the right framework so that they could work. And this is an open call. We cannot do it alone. We are a technology innovation company. We license IMSE technology. And what we want is for all of us to contribute, build databases, build programs, build structures, build plugins, so that designers at a very, very early stage can actually start designing sustainability. Who are we? Typically, this is the first slide you would see in any presentation, but I always think this should be the last slide because it's more important about the content. We are a smart surface company. We've got 100 very smart blokes working on very smart surfaces. We actually work with Covestro, working on verifying, using the films, verifying what we call a stack, a film, component, materials, resins, and then the decorative part. You can see some of our innovations over there in that booth called Nighthawk, as well as right over there, which is a Friend Grill, headquartered in Oulu, Finland, offices all around the world. Should you need more information, just scan that QR code. You can connect with me, connect with us, and there you are. So thank you very much, and I'm looking forward to your questions.
Thank you, Karthikesh. Wonderful presentation, really insightful. I absolutely love the idea of the total circularity cost. We have to really change the way we think about cost and the whole process, bringing designers in really early on. So let me ask the audience, do we have any questions from the audience? This is your chance to ask questions. Yes.
So thank you, Karthikesh, for the presentation. You started with the regulatory framework for the electronics, and as we know, people, designers, other employees, they not always start switching their minds so fast. So what are helpful regulatory frameworks to make your proposal work?
The Eco-Design Directive from EU is actually a very, very good starting point, right? I mean, this is where a lot of activity is happening in that. But when you look at the regulatory framework, it needs to be translated from that regulatory framework into tools that designers can do. So one needs to look at that regulatory framework, the Eco-Design Directive from EU, and then break it down into saying, what does it actually mean from the designers? What does it mean from a rule standpoint for the designers? And then the designers can start using those regulatory frameworks.
All right, do we have any other questions? Yes, Christian.
Yeah, thank you. A very great talk, I must say. Good progress. I see it also at our booth. Maybe a technical question, because films, printing and forming is around for quite some years already. So what was the technical progress you could make to make this possible now?
That's a very, very good question. Yes, films printing was already there all the time, but molding component, having SMT components, that was not there. Having digital plastics, this is actually the innovation, I would say. A digitized chip that we have in a way that can be actually molded with adhesives, and the interface that is digital. And that is actually new because that enables programmability.
Any other questions? So let me ask you, Karthikesh, I mean, you introduced us to the technology, but how does it actually then scale up? Can you scale up production of that?
Now, this is a very, very good question. We are a licensing company. And any disruptive technology has two forces, right? You push technology into the marketplace, and that's what we have been doing. But then the marketplace needs to pull. We saw the very first instance of pull within the automotive sector, and we did extensive work with with an luxury OEM, and we got our technology validated. It went through what I would say, a big validation cycle, and we got a message in our IMSE days, which concluded about 2 weeks ago, that they have validated our stack. It meets the requirements that the automotive industry has. That means that you have the pull in place. As a consequence of that, we actually got component vendors that say they are going to be looking at all components that are IMSE capable. Not like an afterthought, but pretty much in the very first process of design. We also have changed our business model to enable people to be able to design with us. It's called a design and innovate business model. We have got engineering partners who actually are very, very early stage designers involved that take our design rules, our licensing content, and start building with that. So this is the way we'll have to scale. We have got the first pull now. We've got a value proposition that is very well defined, both for the automotive as well as for the aviation sector. We've got component vendors who are now building components for in-mold structural electronics, and then we've got design partners who can design with it. All the ecosystem is coming together. We believe we should have more IMSD-based parts very, very soon.
Sounds very promising. All right. So, and it seems when you talk about it, you're very excited about it. What excites you the most about IMSE?
And there's a reason why I brought this. I mean, there are a lot of things that is cooking at the back burner, as it always is in a technology company, but this one is unique. I mean, we see a lot of structures over here. We see light, we see the way by which electronics is brought into it, but it's always a separate structure. There's nothing in the world that is actually having fully digital integrated single structure in place. And that is what excites me a lot. Personally, it excites me because this means you can have new business models in automotives. You can have a single structure that can sit on a home appliance, that can go into an industrial electronics because it's ruggedized, it's sealed, and at the same time, it can also go into an automotive. This is actually the holy grail, in my opinion, of making plastics digital and making them fit into multiple applications. And that is what excites me a lot.
Wonderful. So since we're talking so much about circular products, circular design, circular economy in general, again, can you just highlight what you think is the most important aspect of IMSE when it comes to enabling circularity and sustainable products?
Another very good question. Pretty much my talk covered also aspects of that. I mean, look at it this way. Circularity needs to be looked at it from different points, right? It's a cradle to cradle. It's not a cradle to grave mechanism. It's a cradle to cradle. And what we mean by that is the ability for us to be able to think through the whole 360 degrees. And when I look at it, it's about how do you recycle? How do you recover? That's the first step. Then once you recover, how do you recycle? Okay, now you have recovered, recycled. Yes, it's there, but that doesn't stop over there. How can you look at product variance? How can you make the same product actually work for multiple functionalities? How can you rethink the way in which electronics and plastics are molded together, human-machine interfaces are built? So this is all part of the circularity chain which actually is missing and which actually IMSE is bringing. And that is why I chose to focus upon total circularity cost today, because that means we have a metric, we have a framework that we can look at other ways rather than just a cost-based assessment of new technologies.
It's very interesting because sometimes we feel this is more of an idealistic discussion that we're leading. We need the circular products, but with a metric that you actually can prove that a total cost, a circularity cost, enables you to also have a business model where it's commercially viable. Then
exactly, yes.
All right.
That's what this is all about, and it's a call to action for all of us to work together to make TCC a reality.
Really, really good. So talk to Karthikesh. He's here if you want to, maybe collaborate or get some insights about the whole process. Thank you very much for coming here from now dark Helsinki. And enjoy the beautiful weather in this
Thank you
as
very
long
much,
as you
Martin.
can.
Yeah.
And thank you for coming.
It's a pleasure
All
for me to be over here.
Thank you. All right, everyone, this concludes the program here at the Covestro Arena. I wish you a wonderful rest of the day here at K 2022, and we'll have a great program here starting tomorrow at 11 a.m. See you then. Bye-bye.